Welcome. Good morning. Thanks for coming. I'll kind of start this a little bit slow because I know people will be filtering in, but yeah, welcome to Advanced Debugging with Firebase Crashlytics. Hopefully you're in the right talk. While this is seemingly my millionth time at GDC, it's my first time speaking, so I figured I might introduce myself. My name is Joe, and in a past life, I worked as a gameplay programmer in educational and VR games, but nowadays I work as an engineer in developer relations at Firebase for Google. There, I write instructionals, make sample games, compile facts, appear in videos, and among other things, get paid to answer Stack Overflow and Unity Forms questions. So if you've ever seen me, please, tell me afterwards or complain about what I've told you. But now, some of you might be asking, wait, what's Firebase? Is there anyone here who has not used Firebase? Oh, okay. Were you dragged here by friends, or how did this happen? Just shout out and answer. Oh, okay. Sounds good. Well, I'm glad to have you. Well, Firebase is Google's app development platform that helps developers build and grow apps and games that users love. Each phase of the game development process requires different tools, from building your game to releasing it to operating it. Firebase provides the tools you need to be successful. As a comprehensive, well-integrated development platform, Firebase offers a variety of products from fully managed infrastructure so you can get your game to market faster, to robust testing, experimentation, and iteration capabilities so you can deliver the best optimized experience for your players, to crash reporting so you can fix bugs fast and find them in your latest release. So today we're going to talk about the last of those, Crashlytics, and how to use its advanced features in Unity to make it easier to identify, reproduce, and fix stability issues in your game. Now that the sales pitch is over, we'll get into the meat of things. Let me paint you a picture of a world, our world, and a story we might all be a little familiar with. All over the globe, small, enthusiastic groups of developers, artists, and designers band together to explore and build their dream games. And oftentimes, their platform of choice is mobile. Some of these small teams of adventurers strike gold with a successful game. Maybe it's an endless runner, mixed with a match 3, an endless thrunner, if you will. It's a blast. Reviews are generally high, and there are only a few negative issues that are easy enough to replicate and fix. Your team didn't mind taking time out of their busy schedule to do this little bit of extra work. At least it was a little bit in the beginning. As the success of the game grows, so does the number of players and new features to keep them immersed in the game's universe. And soon, the trickle of reviews and the issues becomes a torrent. The small company is overwhelmed with how to find enough info about these issues, replicate them, and track them, let alone fix them. The growing company finds a way to reallocate resources to hire a squadron of QA testers and bug fixers. But soon, even these sub-teams start battling new invading forces. Players are demanding more immersive and graphically intensive 3D multiplayer games. Features that used to be fully covered by test matrices grow exponentially out of hand. Suddenly, players are running into overheated CPUs, resulting from a game state game developers didn't even think was possible. Hence, the burning phone. Then there's the ever-growing global proliferation of Android smartphones. No matter how many models of phone the team tests in their lab, players are always showing up using a new device. The once thriving game is plagued with buggy experiences, crashing features, memory vulnerabilities, all of which individual companies are ill-equipped to test and which drive away frustrated players. Has this happened to any of you guys? Sort of just running into a model of phone that you've never heard of? Yeah, I've run into some incredibly obscure hardware bugs that way. So the company is stressed, confused, and hemorrhaging money. And this inability to understand and fix issues isn't isolated to just this one company. It's a chorus of gaming companies, both large and small, across the world, crying out for a solution. I have a pretty specific one. Enter Crashlytics. Crashlytics is Firebase's drop-in SDK that allows apps, and more specifically Unity games, to send crash reports with runtime logs, custom keys for game state, and device-specific metadata. Crashlytics also provides real-time alerts, and these help you track, prioritize, and debug all of the aforementioned issues to roll out fixes faster than ever. Now you can keep your velocity and user satisfaction even higher. So with that sort of intro, we'll just kind of introduce what this is actually about. I just want to highlight that this talk is based on an online learning pathway I made titled Understand Your Game's Crashes Using Advanced Crashlytics Features. That pathway is the most detailed version of this material with instructions on where to get the base sample code, how to change it step by step, and in this talk, I will be skipping many of those steps, but they are included in the docs linked from this QR code. Note that if you only perform the steps presented in these slides and without the steps linked from the QR code, your application will not build. I just want to make that absolutely clear. This is recorded, and so people, please use the QR code. I will also be skipping extra steps needed to make native code issues on Android human readable. For otherwise, you're just going to get, it will just look like C compiler issues, but you get the idea. For Android, you need to manually kick off this process for each new non-editor build. But when building for iOS, this process is handled automatically by Crashlytics. Native symbol upload allows you to better debug issues that occur at some of the deepest levels of your game. So, speaking of your game's native level, Crashlytics also has support for memory debugging that I will introduce after the main presentation. If that interests you, please stick around till the end and we can talk. Finally, note that Crashlytics does not need Google Analytics in order to work, but you can use Google Analytics to add extra valuable information for replicating issues and bugs. I'll detail that when we get further into the talk. I also want to put out another thing. In many sessions, you're able to ask questions. For this one, please keep your questions till the end, and I'll actually be able to speak with you outside afterwards. When I say outside, I mean outside the door. We don't need to go all the way out to the street. So, again, has anyone here used Crashlytics themselves? Okay, cool. Well, some of this might be a refresher for you. In fact, a good deal of it might be a refresher for you. But for the rest of you, we'll talk a little bit more. But, so we're going to start here. The beginning. What better place is there to start? I'm sorry to disappoint or excite you, though, but I'm actually going to skip the sort of spiel about the initialization process with one exception. It's really more of a way of properly classifying exceptions. For those who have used Crashlytics before, have you used, quote-unquote, report uncaught exceptions as fatal? Okay, one person. Cool. Long story short, that is now considered best practice. We've run into a situation where oftentimes when people are using Unity, uncaught exceptions do not crash your game, but they crash it for users effectively, aka the game continues working, but they can't actually interact with it. So now we highly encourage, as shown down here, to set report uncaught exceptions as fatal, because oftentimes that's exactly what happens. You just get a game that hangs, but it's not considered crash. So you might be asking, why would I want to increase the number of exceptions counted as fatal? Because people are often worried about their Google Play metrics and sort of, oh no, I'm not going to be shown to as many users. Well, I want to allay your fears by saying labeling uncaught exceptions as fatal will not affect your Google Play vitals metrics and is only there to help you accurately reflect bug rates and to better prioritize what to fix. So keep that in mind. I would say, underline that note. I almost pointed at the screen until I remembered it's actually not up there. It's just here. But Google Play reports and Crashlytics are actually intended to complement each other. Has anyone here gotten into a situation where they're looking at Google Play crash reports versus Crashlytics and kind of trying to, square the circle and understand the difference between them? Okay, the same guy. Thank you. It sounds like you have a very deep experience with Crashlytics, and I'm glad you're here. He's not a plant, I swear. But Google Play reports and Crashlytics are intended to complement each other. And when an issue is shown in both places, Google Play has the nice benefit of symbolicating system frames, while Crashlytics has higher fidelity within application frames, aka your games. So looking at both will give you the complete picture. This is a takeaway that I really want to underline. Again, if you are looking for system frames, look at Google Play. And if you are looking for your application and want to see it more in depth, look at Crashlytics. So, in a real project, aka not a demo, you would have your game throw an exception and confirm its reception on the Crashlytics backend before doing anything else. This is a necessary step that is often overlooked while people go through the setup, and it leads to people having to go to the support forum and then being told, hey, did you do the intro? And many of them skip that step. But just know you need to throw and confirm that you have gotten a test exception. So, in that case, if we go to the Firebase console and choose the appropriate project, go to Crashlytics, and select the right app, Then we get a list of issues reported to Crashlytics, and these can include caught exceptions, uncaught exceptions, crashes, and in the case of Android, ANRs. So an example of how one of these shows up, in fact, it's the debug exception mentioned earlier. We have this. The name of the game that is in the pathway is called Mecha Hamster, hence why many of the classes are prepended with hamster. It's not just like a cute code word. It's actually a cute mascot instead, so y'all should check it out. It's also a fun game if you've ever gotten a chance to play it. You kind of just roll your phone around and control like a little hamster in a ball going through space. It's a fun time. I made this version of it, but it's modified from an earlier game that the rest of the team had made. But let's check out our pictured, uncaught exception case, which is generally the recommended issue to use as a test. So here you can see that the issue is displayed with its stack trace reflecting where in the code it occurred, over here. And you'll see all sorts of Unity Engine events and then the methods actually attached to it. And then you'll see apparently that it was crashed on the main thread. In addition to all of that, though, if you navigate to the Unity metadata tab, you can see some information specific to the client and device the event occurred in. This includes the version of Unity the client was made with and the system/hardware info and more. Do you guys notice anything odd about the quote-unquote phone that this was done on? Yep, it's a simulator. So this is not exactly representative because, for instance, it's going to have a huge GPU. It's going to have a huge GPU, and like the resolution is going to be a little bit different than you're actually going to get. But you can run this in simulator to do some early tests, and then you can run it on like device. But I took these screenshots in simulator because it made it a lot faster. Anyways, so Crashlytics lets you log a lot of helpful information about a bug in your game. Now, in a real game, all the features that I'm about to talk about would be interspersed throughout the game code to record this information for when and how a bug happened. But for this talk, and in the learning pathway itself, I've created a central place, quote unquote, a debug menu. This would be the equivalent of like an old school game's cheat menu, with several demo methods to artificially demonstrate the use of all these Crashlytics features. This debug menu even has buttons to call the aforementioned methods and cause events to be reported by triggering exceptions and crashes. You can see these over here. I know that I did not choose colors that are super easy to read. Like, check this one out. I don't think I can read it from here. This is my own fault. But we have these custom methods I wrote, such as crash now, which I think you can intuit what that does. Log non-fatal error. Decrypting this, it looks like log strings and crash now. Yep, that's it. Set custom key and crash. Set logs and keys, ANR. Also, these are some Google Analytics events that I'll kind of mention later. But I'm going to give you a little bit of a tour of the methods themselves. These can be found in assets/hamster/script/states/debugmenu.cs. Don't worry, you will be quizzed on that later. And if you don't answer properly, I won't answer your questions later. So we'll start with the aptly named crash now method. Again, this is a custom method. This is not part of Crashlytics. But if we press crash now in the simulator, then predictably, the game stops. But note that with the game built in some versions of Unity, you may need to press it twice for some reason. I'm not exactly sure. And I see a man nodding over there. And yeah, it's just for whatever reason, certain editions of Unity are like, yeah, you got to crash twice to really crash. Just you got to mean it, It doesn't pop up a dialogue or anything. You just got to really mean it. But if you've ever had a crash in your game that you have been unable to explain, this method will demonstrate what information about the crash you can get automatically from Crashlytics. This method, and many of the others, calls another custom method named testCrash to crash the program when run on a physical mobile device or simulator. I lighted putting my testCrash method in here simply because it's full of a lot of compilation-specific code, and I didn't want to have to explain some of that. But also, if you try calling this in the editor, if I didn't put in an error log that yelled at you for trying to do so, it would crash your editor, which is not exactly helpful or useful, really. Just, good to know. If you want to check out the source code, you can find out how to crash your editor if that's something you ever wanted to do. So we'll take a look at the Crashlytics dashboard and see how it displays. As you can see, this is recorded as a crash. Just like the uncaught exception before, if you click the event, you can see the stack trace and therefore code path that led up to the crash. So just check it out. It's just marked as a crash. The details of this are not as important because, again, this is run on an iOS simulator. It's not really a great example if we were to like really dig in. But you know, like what would you do if you have a non-fatal exception that you've caught that you still want to record? Something like a failure to connect to a game server. How would you go about recording this? Those of you who have used Crashlytics, do you have a good idea of how? Okay, shout it out. Bingo. And so the way that you would do that would be to, log a non-fatal. So I have this custom method, log non-fatal error, and you'll notice that it's calling the Crashlytics method log exception, which allows you to log a caught exception and have it not marked as fatal. So sometimes developers like you are aware an exception can occur and wrap the code that might do so in a try-catch block. Even though this exception was caught and the program was returned to a known state, it can be useful to record this exception as an error to be looked at while debugging. Log non-fatal error passes a caught exception to crashlytics.log exception to be logged as a distinct issue in the Crashlytics dashboard. So you'll see I'm just throwing a system.exception with some self-explanatory text, and then catching a system.exception. In a real case, you should obviously make that a much narrower case of exceptions. This is generally not best practice, but I just kind of wanted to save us some time here. So the way it displays, the big difference is it is labeled non-fatal. And this is, again, called from the debug menu. And notice the crash-free statistics, I was going to say are crash-free, but that's actually no data, so sort of different situation, but gets the idea across. So I want to talk a little bit more about how you would assemble sort of like a record of events that can lead up to a crash. This is something that's often useful. When you all were intro CS students, assuming you went, the academic route, did you guys do a lot of print line debugging? Yeah, I'm glad everyone's nodding their heads because I didn't want to feel alone up here. But this is kind of the more advanced equivalent of just keeping a running log of what your system is up to. But let's discuss log strings and crash now, which kind of tells you exactly what it does. But have you ever run to a crash where you wish you were able to isolate what the user was doing beforehand to understand their user journey that led up to the crash? Well, predictably, now you can. So this method uses crashlytics.log to log a string, notice not an exception, a string, to Crashlytics before using the custom method testCrash to crash the game. I'll show you. There are 4 places it's used. There's right here, right here, right here, and right here. Can you tell me, incredibly elementary question, but how many of these do you think will come through, quote unquote? Okay, yeah, someone has the right answer with 3. This is because, obviously it only matters where these are called, and this is to indicate like, hey, it will show you the path the logic took instead of like just like where it's included. It's not just like some macro that like auto fires or something. So when we actually go to the logs, this will kind of show up. Of note, this will not record the log strings as independent issues. These will actually all be subsumed under a subsequent event, and that is the test crash over here. And the question is, why would you do that? Well, as mentioned earlier, the test crash shows up in the dashboard under the same issue as the test crash from earlier, because things that are similar crashes / occur in the same place are logged together with some slight exceptions that I won't get into the magic of that. But when you click into the details, though, as predicted, you'll see those 3 strings. They'll just tell you a little bit about what's going on. Again, they're not on their own. Assuming the logic was a little bit more complex than my toy example here, you can use this sort of information to create a record of events that led up to this crash. And from this information, you or your testers can reproduce what paths users had to take to cause an issue. So let's say you just have a game where people, like, for some reason, if someone does something like very odd in the game, like they play like a very weird hand of cards, like let's say you have a TCG. I'm just really riffing here. And like, let's say you find like a way to have like a broken sort of stack of options in the game. Like you just cause like an endless loop of conditions. This happens in Magic the Gathering, which for anyone who doesn't know is actually Turing complete, apparently. So like, yeah, you can get all sorts of like goofy stuff to happen. And so if you made a TCG and were unmindful of the fact that you can create a Turing tar pit, you can run into the situation. So it's nice to have the crash logs. But on a related note, any events logged to Google Analytics in the same session as an event will also similarly show up and can be used to help reconstruct the path that led up to the event. So I've kind of run into some issues where I have clients who, when I say clients in this case, I mean professionals who are making games rather than the client that you're running, but who sometimes use Crashlytics and not Google Analytics, or Google Analytics and not Crashlytics. And I would say that if you have reason to use both, you should use both because they play very well together, and it's very helpful to have that extra information in your session. But so now that we've been able to reconstruct sort of user journeys, what if instead of the full path the app took to get to an event, you just wanted a subset of the final game state? Like, let's say you knew that something was wrong about like a mix of variables that was occurring, but you weren't sure what exactly is causing it. How could you save only the most recent states of the variables in the game? Those who've used Crashlytics, do you have a good idea on this one? Yes. Okay. Okay. I'm so glad you are here. This is the level of audience, participation I could not have relied on. But so oftentimes when a crash occurs, the program is in a state where variables are assigned incompatible values that the developers did not foresee as being possible or harmful. I've definitely been in this situation. But the method I'm about to describe can be used to note the final state of the game at the time of an event. So this custom method, set and overwrite custom keys then crash. I'm a huge fan of overly self-explanatory names. Sets a record to custom key value pairs representing state and allowing for easy searching of Crashlytics issues. So you'll see here Crashlytics.set custom key and another call of it here, where you basically map key value pairs. So in this case, this is the key, this is the value, and the values must be strings. So even though this thing actually spits out an enum or enum, however you want to pronounce it, I always say enum, you have to cast it to a string. But if you have assigned a key value pair, when an issue occurs, the custom keys are included. To make searching these more efficient, it is highly recommended that you try to use a small set of possible values. One way of doing this is called discretizing the range of values. In this process, potential values are mapped to a smaller set, such as a custom enum or a set of strings, to make categorization easier. In the case of set and overwrite custom key then crash, the code contains a method for mapping time span values, interpreted as time of day, to what phase of the day they are in. So you see that here with daydivision.getPartOfDay. That's just a custom method that's in the source if you guys want to check it out. That's not some intrinsic part of C# or the .NET library or something like that. But I simulate time passing by adding a duration, named something very related to this, which is a duration that ensures phase change. So in this case, the phases are morning, noon, afternoon, evening, and night. So basically, this just makes it so that it has to switch between them, and then it sets the custom key again. The value mapped to the current time key is left only with the last state after adding a time span. And so basically, instead of getting what the first one would be, which is morning, you'll get probably, I forget what value I actually put in duration that ensures phase change, but I'm just going to guess you get afternoon. But oftentimes when I check it, you get night. So that probably says a lot more about when I'm testing this program / when I work rather than what time it is right now. From there, you can filter based on the value of the key, making it easier to determine the impact of a value or state, including it. So if you have, let's say instead of just this small project where you have only 4 issues, you have a project that has hundreds of issues, not because your game is super buggy, but because you run into a lot of problems when you release a global scale. You can filter by different key value pairs, and because of that, you can get some much more specific issues. And it's very useful, especially if you're looking for something related to one of those. Sounds good. Okay. So finally, we arrive at set logs and keys before ANR. This method uses logging and custom keys in order to help diagnose what methods or code paths might be causing an ANR. This is actually something that I think is a takeaway for this session, because this is what I would have wanted to know a couple of years ago. So when the UI thread of an Android app is blocked for too long, an application not responding / ANR error is triggered. If an app is in the foreground, the system displays a dialog that gives the user the opportunity to force quit the app. Unlike many Android apps, the Unity main thread, actually, before I read this, does anyone know something weird about the Unity main thread relative to Android development generally? It's not the UI thread. And so because of that, ANRs are kind of a notoriously difficult class of issues to fix in Unity specifically because they inherently involve multi-threaded code. And the method can help, this method and kind of like ideas built from it can help make diagnosing and fixing these issues easier when calls to other threads are exposed or can have callbacks attached to them. This function fundamentally can't create an ANR on iOS because that's not a thing. So I've left it up as an exercise for the viewer to try this out at home. But instead, I'll just explain what's going on here. So if you look at this code, is this actually readable to those in the back? Oh, I'm sorry, y'all. Well, again, the source is available publicly online, so you can check it out. But long story short, I'm starting a stopwatch, and then I set a custom key for like what method is being run. The stopwatch starts running. I start a busy wait simulator, aka something that starts something on the main UI thread. And then once that is done, I stop and I record whether or not something was in danger of causing an ANR or not. And the reason for using both keys and logs is because simply using both, you can do some interesting deductive reasoning. So if something is set, if you have a log that shows that something started running and it is recorded as the current method, but it never shows the finish one, you know that that caused it. And this is overly simplistic as a model of ANRs. Like Crashlytics has actually very good support for diagnosing this at more of a thread-to-thread level, but this is a way of making it sort of more human understandable as you're doing this. You can also create, call stacks and like ANR records as you do this, but just go through the code, check it out, and you'll notice a little bit more. But I was going to say, why would you do this? But the answer is I kind of already told you. So I'll just go forward. So that was a lot. And now you can use Crashlytics to generate better issues, record information that helps you reproduce them, and more. So I just kind of want to summarize the main takeaways, and we can handle more complicated questions afterwards. But number one, always have your game throw a test exception and confirm its reception as part of setup. This is necessary and will save you a ton of time problem solving and debugging. So when building for Android, so number two, when building for Android, make sure to upload native symbols as part of every build you expect to get issue reports on. Since this is scriptable, you can always add this to your build process to save time and ensure consistency. 3, use Crashlytics.log and Google Analytics events to record interactions and events leading up to the generation of an issue. 4, use Crashlytics.setCustomKey to map any particular value to keys of your creation. They only reflect the final state of the key and can thus be used to determine the program state at the time of an issue. And finally, 5, use the Unity-specific Crashlytics metadata to narrow down issues to specific devices and build features like the CPU model/specs, all sorts of GPU metrics, and the Unity version it was built with. So I have some other stuff. We're running out of time. I'll just run through this very quickly, but these are not things that are actually built into Crashlytics, but play well with Crashlytics. If you all have not checked it out before, check out GWP ASAN, which I recently found is actually properly pronounced very Stewie from Family Guy style. It's actually GWP ASAN, but it's a lightweight memory sanitizer, and they surface as Crashlytics issues. If you all has anyone here used ASAN generally? Okay, well, it's awesome, but the problem is it leads to apps being very slow. GWP ASAN is actually really cool because it operates across your entire fleet of games and is much more efficient because it just protects small memory segments instead of looking at the entire thing. But it can get you a really good sampled idea of how your game performs. Again, you probably need some critical mass of like how many users are using it, but you're going to want to check that out. Are you guys familiar with Unity's Profiler Recorder, the class? Okay, I'm glad some people have nodded their heads. Long story short, if you haven't used it, check out Unity's Profiler Recorder. You can get profiling information in release games, which blew my mind when I figured this out. But you can discretize, again, that's the magic word of the day, discretize the things you get from that into like quartiles of like memory usage and map those into Crashlytics custom keys to get a better idea of performance issues that are affecting your game and possibly causing ANRs or crashes. And finally, look into Crashlytics crash-free sessions. This actually is, directly Crashlytics related. But this is available since Unity Crashlytics SDK for Unity 11.7.0 and above. You'll have a better idea of the health of your app using sessions rather than crash-free days or crash-free other statistics. So definitely check those out. For any more questions or anything that you would like to talk about, I'm available afterwards. But thank you very much for attending this talk.